Welcome to the command pattern, one of the most versatile tools in the behavioral patterns toolkit. By the end of this video, you will know what problem it solves, how to recognize its 4 named participants in a codebase, how to write a working example from scratch, and when the pattern is overkill and you should reach for something simpler. Imagine a text editor where every toolbar button directly calls a method on the document object. That seems fine at first, but the moment you need undo history, action queuing, or macro recording, you are stuck. There is no object you can hold on to, replay or reverse. The invoker, the button, is tightly coupled to the receiver, the document, and every new feature tears open both sides of that coupling. Think about ordering at a restaurant. You do not instruct the chef directly. You write your request on an order slip and give it to the waiter. That slip is a self-contained object. It knows what to do. It can sit in a queue. It can be passed to any chef, and it can be voided before the kitchen ever sees it. The command pattern works exactly the same way. It packages a request as a standalone object, so the caller never needs to know who fulfills it or how. The command pattern defines 4 named participants. The command interface declares a single execute method. That uniform surface is what makes every command interchangeable. A ConcreteCommand implements that interface, holding a reference to a receiver and calling the right method on it. The invoker stores and fires commands without caring what they do. Finally, the client is the code that assembles everything. It creates the ConcreteCommand, injects the receiver into it, and hands it to the invoker. Start at the top with the command interface. It declares execute and undo, the 2 operations every command must support. Next is the receiver text editor, which owns the real logic. Insert appends a word to the internal text string, and delete trims it back. The ConcreteCommand, insert command, holds a reference to an editor instance, and the word it will insert, those are stored in the constructor. Its execute method delegates to editor.insert, and its undo method delegates to editor.delete, reversing the change cleanly. The invoker, command history, keeps an array called history. Its run method calls execute on the incoming command, and then pushes that command onto the array so it can be undone later. Its undo last method pops the most recent command off the stack and calls undo on it. Finally, the client code at the bottom creates a text editor and a command history, then calls history.run with 2 insert command instances. Notice the client wires the pieces together, but the history object never imports or mentions text editor. That decoupling is the whole point. The central consequence of this pattern is that the invoker becomes completely independent of the receiver. You can drop any ConcreteCommand into the invoker and it just works, because they all speak the same execute interface. That also means commands are values. You can store them in an array for undo history, push them onto a job queue, serialize them to disk for audit logging, or replay them in a macro. The cost is a proliferation of small classes, 1 per operation, which is a real trade-off worth acknowledging when the operation set is tiny. Reach for command when you can clearly identify a need for undo history, queuing, logging, or macro replay. Those are the 4 scenarios where packaging a request as an object pays for itself immediately. Skip it when a simple callback or an inline function solves the problem. JavaScript and TypeScript support first-class functions natively, so passing a closure to an event listener is already a lightweight version of this idea. If you have 2 operations and no undo requirement, a whole class hierarchy is unnecessary ceremony. To recap, the command pattern turns a request into a standalone object, giving you a uniform execute interface that any invoker can call without knowing the receiver. The 4 participants, command, ConcreteCommand, receiver, and invoker, each have a clear single responsibility. Storing those objects is what unlocks undo, queuing, and logging almost for free. And remember, if all you need is a one-shot action, a plain function is both simpler and idiomatic. Reach for command when the operation lifecycle genuinely demands it.